All right, here we are in Intermediate Algebra, Chapter 1, Section 5, talking about compound inequalities. And again, this is going to be a fairly short lesson. We're going to look at set notation and then inequalities. And there are two different types of inequalities. One involves the word and, which results in a compound inequality. The other involves or, which will require us to work with two different inequalities. We'll be using interval notation again, but first we're going to start out with a little conversation about intersection and union as pertains to sets. At the top you see an illustration. These are called Venn diagrams, these overlapping circles, and on the left hand side here we see that A and B are overlapping, and this notation right here with the U between the A and the B indicates union. That's why underneath it says A union B. That's how you would read it aloud. And what it means is that we're interested in the elements that are in A or B or both. We won't end up double counting the elements that are in the overlapping section. That's what they have in common. But we sort of take all the stuff from A and B and we pour them into one container and we take out any duplicates. And you'll see what that means or what that looks like in our first example. But before that, on the right hand side, we see that A and B are overlapping, but only the middle region is shaded. And that's because we're looking at the intersection between these two sets. And in other words, we're wondering, what elements are in A and B? In other words, what do they have in common? So let's translate that into a word problem, or rather, it's not much of a word problem, but let's have a look at an example. But be aware, before that, it's possible that two sets will have nothing in common. And if that's the case, sometimes you'll express your answer as no solution. You might express your answer as a pair of set braces that don't have anything in between them. Or you could use this circle with a slash through it. But you're not going to use this last notation, which combines those two. Don't use that one. That's not the empty set. But the other two that I circled in purple are considered the empty set or the null set, N-U-L-L, and those are representative of no solution. So let's see in this first example, we've got set A and set B, and we want the union of those two. We're going to put our results inside set braces. And as we combine these two sets, or we ask what's in A and in B and in both, I see that there's a 1 in set A. In set A and set B, there's a 2, but I'm only going to write the 2 down once. That's why I said remove any duplicates. And there's a 3, and there's a 4, and a 5, and a 6, and a 7, and an 8, and a 9, and a 10. So that's the union of A and B. The second part of this question wants the intersection, so I'm only concerned with what these two sets have in common. So let's get our set braces here, and they don't both contain a 1. They do have a 2 in common. Do they both have a 3? No. 4? No. 5? No. 6? No. 7? No. 8? No. 9? No. 10. 2 is the only number that they have in common. So the intersection of these two sets only contains the element 2. Now something that might look a little bit more mathematical is what's called a compound inequality. And in order to solve a compound inequality, you can read what's in this yellow box. But essentially, we're going to be working this thing using the techniques and maneuvers and rules that are very similar to working with an equation, except we're operating in three, I call them regions, there's this left-hand side, and then there's this middle region, and then the right-hand side. And what we do to one region, we will do to all three, which sounds a lot like when you're working with an equation, what you do to one side, you do to the other. But we're going to attack all three at the same time, and the goal is going to be to get x all alone, or whatever your variable is, all alone in that middle region. So let's see. The first thing I'm going to do is get rid of this 9 that's in here. So let's subtract 9 from all three regions. 21 minus 9 makes negative 30. That's less than or equal to negative 2/3 x. We've subtracted out the 9, so that's not there anymore. And it's strictly less than 7 minus 9 makes negative 2. And if you want to put a little note here that we subtracted 9 from all three regions, you could do that. What are we going to do next? I'm going to do this in 2 steps, actually. The first thing I'm going to do is I'm going to get rid of this negative sign that's in the middle. So let's multiply this entire statement by negative 1. That'll change the negative 30 into a positive 30. The negative 2/3 x will become a positive 2/3 x. Negative 2 becomes positive 2. And the thing we need to be very careful of, that you need to remember, is that when you're multiplying an inequality by, or dividing an inequality by a negative number, we're going to switch the signs, or flip the signs, or change the direction of the inequalities. However you want to phrase it, make sure that it happens. This inequality symbol is now facing the other direction, and this one needs to also be facing the other direction. So use a different colored pen, highlight it, use a glitter pen and circle them, something, but make sure you don't miss that maneuver. The next thing, and the last thing I'm going to do, is I need to get rid of this 2/3, and I'm going to make that happen by multiplying by the reciprocal. So I'm going to multiply everything by 3/2, and 30 times 3/2 is 30 times 3 divided by 2, which is 45. And I'm getting a little tight on space here. Let's see if I can make it fit. That becomes a 45. Is still greater than or equal to now just the x, which is greater than 3. Because the 2's cancel and we're left with 3. So 45 greater than or equal to x greater than 3. This is a little weird because it's kind of backwards. 45 on the number line is not to the left of the number 3. So I'm going to rewrite this again, sort of taking the entire statement and flipping it. 3 will be on the left-hand side, less than x less than or equal to 45. Notice that the 3 is still on the sort of pointy side of that inequality symbol. It's still on the less than side. The x is on the less than side of the 45, and it is here still also on the pointy side of the 45. So we're in good shape. We've rewritten it or flipped it correctly, and that could be your solution, your answer to the problem. We could also use set builder notation, wrap it in parentheses, set of x values such that 3 is less than x is less than or equal to 45. Or the more typical way, you could put it on a number line also. The most typical way that we're going to see this is written like this. The parenthesis is happening here because this is a strict inequality. It does not contain the less than or equal to symbol. And the square bracket to the right of the 45 is the result of this being a less than or equal to symbol. The or equal to makes that closed on the high end of our interval, and the parenthesis means we are open on the low end of the interval. So again, interval notation, You're going to be answering a lot of these questions using interval notation. Let's look at another kind of inequality, compound inequality. This one involves the word or, and this problem, number 3, has been set up for us with two inequality statements literally separated by the word or. We'll run into absolute value inequalities where we're going to have to realize that the word or is involved instead of the word and, but at the moment it's sort of being given to us on a silver platter here. Let's see if we can, let's be a little clever here, because I'm a little short on space. Hopefully you're using a larger piece of paper than I am. I'm going to work on this inequality in purple, and then I'll switch over and work the other one with, let's say, red. That'll help us distinguish the two. And in this first inequality, I'm not going to distribute multiplication by -3. I want the x to be all alone on the left-hand side, so I'm not going to bring the -3 even closer to it. I'm going to get that -3 out of there. Let's divide both sides by -3. And here again, I'm dividing by a negative number, so we'll be flipping the inequality symbol. On the left-hand side, the -3's cancel, leaving us just with x minus 7. Flipping the inequality symbol, 15 divided by -3 makes -5. And then I will add 7 to both sides. So my left side is an x, and my right side is a 2. So x is less than 2. That's going to be part of my solution. Then I'll switch over to red, where that looks a little bit more like an orange. And let's get the word or in there. Or. And in this statement, all we have to do is subtract 2 from both sides. That's nice. So we get x is less than 3. I don't love that, but every once in a while you're going to run into a situation like this. Or should I just change it? Let's change it. I'm going to modify this problem. In this red or second inequality that we were working on, let's change this symbol to a greater than symbol. Now, let me give you a couple of seconds to erase that less than symbol, change it to a greater than symbol. I'll erase my one that I wrote down, and I'll change that one to a greater than symbol. We still subtracted 2 from both sides, but now I end up with x is greater than 3. And that's it. I can circle that one. I've isolated my x value. So what does it mean that x is, like, how do I present this as a final answer? Let's do it 2 different ways. Let me use yet a different color maybe. Let's use this really bright kind of fuchsia color. On a number line, I'm going to take these 2 components, put them on a number line. We'll get the 2 on there and the 3 is on there. And my first inequality says that we like the x values that are less than 2. So I'm shading to the left of the number 2, and I'm going to put an arrow on that shading because it goes all the way down to -infinity. And it's a strict inequality, so I'm going to put a parenthesis at the 2. And at 3, it's also a strict inequality, so that's going to get a parenthesis also, and then we're shading that part of the number line with an arrow sending the shading all the way up to +infinity. So this is one possible way of presenting your solution. This is if you were asked to graph your answer or the solution to the inequality, you would write it like this. In interval notation, again, it's really nice. We can read this from left to right and just translate it straight down into interval notation. From left to right, I'm going all the way down to -infinity, which means I need to use a parenthesis at -infinity. The shading comes all the way up to 2. That same parenthesis off the number line comes down. At 3, it's also got a parenthesis. The shading goes all the way up to +infinity, which always takes the parenthesis or open bracket. And how do I turn these 2 intervals into one answer? How do I indicate the word or? That x values from the left interval or the right interval are acceptable? We use the union symbol. we unite those two intervals, sort of pouring all of those answers into one container of acceptable answers. We unite them with the union symbol, and you got yourself a final answer in interval notation. It's a little intense. Boy, when I zoom out, it looks so small. All right, let's keep moving. Applications of compound inequalities. Inclusive, exclusive, square brackets, parentheses, you can read that. I'm going to go directly into this example problem. So on the first of 4 exams, your grades are these. There's still a final exam, and it counts as 2 exams. Final exam counts as 2 grades, 2 test grades presumably, and you're hoping to get a C in the course. A lot of algebra students would kill for a C, right? C is passing. So based on where we are in the semester, we're thinking, let's just make sure that we get a C. Let's figure out what we need on our final exam so that when we average all 6 of those test scores, because remember your final exam counts as 2, we've got 4 test scores here plus 2 from the final. We want that average to put us in the C range. So we need to get between a 70 and an 80. And what this says is that we need our final score for the course to be greater than or equal to 70 and less than 80. I'm pausing here because there's a very little subtlety to that. Greater than or equal to 70 and less than 80. That's strictly less than 80. So we have to translate this as the instructions said. Look, it says right there. It says translate and solve. So let's translate this. How are we going to find the average of all of our scores? We add them up and divide by the number of scores. So we've got a 79 and an 87 and a 70 and an 80, and my final exam score counts as 2 test scores, so that whatever I get on it, I'm going to have to add it in twice. So it's like having 6 scores, so to average them we'll divide by 6, and we were told that we need that average to be greater than or equal to 70 and less than 80. The translation part of a word problem into a mathematical statement is often one of the most difficult parts of the process. So if you struggle with that, that's fine. You're right there with everybody else. Just realize that it's part of the process you really need to work on. All right, let's solve this thing. Again, we've got a fraction in our inequality statement. I don't like it. I'm going to get rid of the 6 right away. Let's multiply this whole thing by 6. 70 times 6. 420. Let's go ahead and do this arithmetic and this arithmetic. The 6 in the denominator is going to go away. It's going to cancel out. That's why we were multiplying by 6 in the first place, was to get rid of that denominator. So let's use our trusty calculator so that we don't mess up the arithmetic. I don't do these problems out in advance. I want to do them with you so that you can see the whole solution process. So I've got 79 plus 87 plus 70 plus 80. So just adding those numbers together gives me 316. And we don't want to forget those 2 test scores. X plus x makes 2x. And that's got to be less than, strictly less than, 6 times 80. Don't forget to multiply that by 6 also. So 6 times 8 is 48 with a 0 at the end. And we're getting pretty darn close. Couple of steps and we're going to be there. we've got to get the x all alone in the middle, so let's subtract 316 from all three regions. 420 minus 316. The 4 minus the 3 gives me a 1. 20 minus 16 gives me a 4. Less than or equal to. The 2x is still there. Strictly less than. 4 minus 3 is a 1. 80 minus 16, 80, 70, 64. All right, we're getting close. Let's get rid of the 2 in front of the x, dividing both sides, or I should say all three regions, by 2. 104 over 2 is 52. Get it together. There we go. Nope. Every time I put my hand down, the screen seems to move. Is less than or equal to just x, strictly less than. You can keep, I don't like it. Let's keep it all lined up. Less than or equal to x, strictly less than 82. So, using English, our final exam score needs to be greater than or equal to 52 and less than 82 if we're going to get a C, guaranteed to get a C for the course. On a number line, why not? 52, 82. We need to include the score of 52, so I'll do that with a square bracket. We'll exclude the 82 using an open bracket or parenthesis, and then we could shade everything between. Translate that into interval notation, which is the very desirable way to present our solution to this type of problem. We bring the square bracket down with the 52, going all the way up to 82, which we're excluding with a parenthesis. Those are the scores that you would need to get a C. I'd much rather that you got a B, but if we're passing the class, that means that we've got some of the basics down. We're happy, we're moving forward. My students would go on to college algebra. I have made like 12 videos today, so I'm going to sleep. Thanks for hanging out with me. See you next time.